your fingers on it.
It's actually not that sharp.
Can you guys see my screen?
Yep.
Yes, we can.
Yes.
Oh,
Yeah.
so here we go. So guys, I bring to you a good article about the basics of system design. Actually, this is a article for a tutorial for Geeks. I guess you guys know this website. I'm gonna share the link before this meeting. So yeah, let's start with this article. It's a simple getting started about system design. So it's all about the process and the fundamentals of this kind of interview. So I'm gonna start to read and then you can share thoughts about that. So basically, system design is a process of designing the architecture and components of a software system to meet specific business requirements. So the process involves defining the system's architecture, components, modules, and interface, and identify the technology and tools that will be used to implement the system. So it's a really common process of senior interviews. It's more common in senior position, but you also can see in mid-level positions. But yeah, basically is a process to evaluate if the interviewee can build a solution to meet some specific requirements. So you have to know about everything in architecture, like technology, like some distributed system, microservice, and so on and so forth. So for that, you have to bring uh, a long time of experience, and probably you are a senior, you have a long-term career in technology. So yeah, you meet very many different like many different technology fundamentals of computer science. So here are some steps for getting started with system design. So we have here 7 main steps. The first one is understand the requirements. So before you begin design the system, you need to understand the requirements. This involves talking to stakeholders and users, reviewing existing documentation, and analyze the business process that the system will support. This is a great point because uh, most of the time the interviewer want delivery all the requirements. So you have to ask them about what the systems needs. Like for example, at the glance, at the first touch is okay. We wanna build a Spotify system, and how do you deal with this? So the first step is okay. Uh, what kind of file do you want to deal? Which are the users? How do you wanna provide the systems to interface or something like that? So the the interviewer won't deliver to you all the requirements. So you have to ask them and describe the the requirements to go to the next step. That is the define the system architecture. So once you have a clear understanding of the requirements, you can begin define the system architecture. This involves identify the major components of the system and interface between them. So it's the second step is draw a big picture of your system. So once you have all the requirements, or most of them, you can start draw the components of the solution. So it's like a big picture with the main module and main components of the system. Um, so after that, you can choose a technology stack. So basically on the requirements in the system architecture, you can select the technology stack. This includes choosing the program language, database, frameworks, and libraries that you use to implement the system. So I guess this step, this step, the three data view will start like starts make questions to you about why are you taking this decision. So why are you choosing this database? So this database can meet these requirements. So each choose you do in this step is a point to think about it uh, and start the justifying of the choice of this technology. So the next step is design the module. So next you need to design the module that will make up the system. This will define the functions that each module will perform and the data that you will manipulate. So you guys can see that we go deeper as the while you are getting while you are going through the steps. So designing more modules is more related to the functionality of the systems. And then you can start to talk about scalability. So as you design the system, you need to consider how it scale. This involves identify potential bottlenecks and design the system to handle increased loads. So this is a good opportunity to show to the interviewer that you can scale a system that you have experience scale systems. And then you can consider security and privacy. So security and privacy should be a key consideration in system design. This involves identifying potential security threats and design this system to migrate them. This is another key point of system design is about security, privacy, and then they can ask you about authentications method and like if you have some experience you work with some specific method and so on. And then the final step is test and validation. So once the system design is complete, you need to test and validate it. This involves creating test case and scenarios that simulate real world usage and verifying that the system meets the requirements. So this is the last step is when you prove that your design works to the scenario that was proposed. So overall, system design is a complex process that requires careful planning and attention to detail. By following these steps, you can create a system design that meets the needs of user and your business.
Can I ask a quick
So,
question?
mhm,
On average, how long are system design interviews from the very
mm,
beginning to the end?
usually it takes like 40 minutes or 5 minutes, 5 minutes,
40 to 50 minutes?
50 minutes, yeah.
Okay, okay. Gotcha.
So it's
And how is that, how's everything divided? Are you gonna go into that?
defining which means what do you mean
How's
like
the process divided during the interview? Like how many minutes are they gonna be asking you questions and telling you about the requirements, and how many minutes are
mm,
you gonna be given to actually draw the app?
I guess there is a not clear definition about that. It's
Mhm.
like you the interviewee can deal with that. So you have to use like all this time to go through all the steps here, like understand the
Mhm.
requirement, choose the technology. So Uh,
Mm-hmm.
and and then if you need some time, probably you can ask for it.
Gotcha. Thank
So
you.
yeah, it's not a defined time for each step. But like I said before, it's very useful. Use your time to the first steps. The first step here is that you understand the requirements. So because using these requirements will guide you to design the solution. Um, and to be honest, this is a, this is the main point of the interviewer, but because the interviewer don't want to see just the technology knowledge, just like the hard skills. They want to see if you can understand the problem. So if you can understand clear the problem, you can deal with other problems. So because soft skills is very easy is easier to get if you are a senior developer, for example, a new technology, a new database, and so on. So for me, and this is the main step, understand the requirements. So when you are given a system design problem, you should approach it in a planned manner. This is what we were talking about. You can control your time. So you have to go with a planned manner to divide your time in each step, in steps. So with the steps, you can guide the the design better. Initially, the problem may look huge, and one you can easily get confused about how to start solving. Yeah, it's very common. You see the problem, and oh, I don't know what to do. But this is the step that you can ask the interviewer about the requirements, and and then it will be clear. And moreover, there is no fixed solution while design a system. Yeah, there is another fixed solution, and there is more than one way to read the solution. It's important because uh they don't want you to write the best solution, the unique solution. They want to see how you can uh, they want to see your think process, how you can evaluate the design and solve the problem. So there is another steps here, like approach and design problem. Are you guys have some doubts or some questions? I would like to listen to you guys. Have you guys already did some system design interview?
I think
Actually,
Denard has
I've
it, right?
been hearing a lot about something pretty new that GDPR has brought to us. There is some concepts that are called privacy by design and privacy by default, which states that we must consider privacy and security concerns from the very beginning of the process. So when you are eliciting your system requirements, when you're designing your architecture, when you're uh, going through all those steps that you describe, you must consider the security and privacy aspects from the very beginning. So that's something very new. I'm not sure if uh, on an interview those things may be considered, may be regarded as something important, but I've seen so much talk about those privacy stuff that I think
Yeah,
that would be something important to learn.
yeah. It's like a cross concern, so you have to take care of privacy all the steps.
Yeah, because there's one step that talks about security and privacy in your approach. Go up a little bit. The number
Is there
6.
6? Yeah.
So the way it's laid out, it may lead you to think that you should consider security and privacy after you understand the requirements, design the system
Yeah.
architecture, choose the technology stack, and so on and so forth. So what I think those new concepts are concerned with is that you must do this from the very beginning, from step one.
Yeah. So in the requirements, so one of the requirements is security and privacy.
Yeah.
It's a good approach. Yeah, for sure. So nice point, Denard. Uh, let's talk about approach to design problem. Um, so discuss like how solve a design problem given an interview. So break down the problem. So when you are given a design problem, start breaking it down in small components. This is break down the components, break down the problem. So these components can be servers or features, which you need to implement in the system. Initially, a system give to be designed can have a large number of features, and you are not expected to design everything in this interview. So it's a good point because you have to take care about the main features. You don't have to develop all these features or describe all these features or all the components. Uh, and ask your interviewer about the features you are planning to put in your system. Is there anything else you should be put in that? Any feature in SAV? Ask. So, yeah, this is the most important thing. You have to ask your interview about to understand the requirements and what the system is going to do. Communicate your ideas. Communicate well with the interviewer. So while you design the system, keep him in the loop. So while you are drawing, design the system, keep the communication clear. This is really this is a challenge, to be honest, because uh, since you are talking English, you have to pay attention in your English in your design. So it's a good point to practice. Like so one of the tip is start recording yourself designing and talking with a fake interviewer, for example, because this is gonna make clear and in a future interview, and discuss your process out loud. Is the same mean. Try to demonstrate your design clearly on the whiteboard with flow chart in diagrams. These are default design using flow chart and diagrams. Describe your ideas to your interviewer. How you have planned to tackle the problem of scalability. How you'll be designing your database and many others. So communication is a good point in this process. Assumption that makes sense. Makes some reasonable assumptions while you are designing the system. So suppose you have to assume the number requests the system will processed per day, the numbers of database calls made in a month, or the efficiency rate of your cache system. These are some of numbers you need to assume while in design. Try to keep this number as reasonable as possible. Back up your assumption with some facts and figures. This is a good division of a mid-level and a senior developer. The senior developer starts the interview asking about this number. So how many requests will be proceeded, how the number of database calls made. So you're gonna design your solution use these numbers. and it's important to prove that your design can handle these numbers, or it can handle this process. Now we know how to approach a design problem, but in order to succeed in an interview or successfully build a scalable system, we need to ensure that our system is reliable, available, scalable, and maintainable. So we should have knowledge of all these terms are and how they impact your system in long term. Yeah, these three, there are the three main points of a scalable system is reliability, availability, scalability. So we can discuss, let me see the time here. Okay, I guess we can go through the first, so yeah, we have time. So a system is reliable when it can meet the end user requirements. So when you're designing a system, you should have planned to implement a set of features and servers in your system. If your system can serve all these features without wearing out, then your system can be considered reliable. Yeah. A fault-tolerant system can be one of the that can continue to be functionally reliable even in presence of fault. So fault tolerance uh, is the resource that you can the system can be up even with errors or even with less resources, for example. So variable is a set of features that you can that your system has to implement in order to reach it. Availability is a characteristic of system that aims to ensure an agreed level of operation performance, also known as uptime. It's essential for a system to ensure high availability in order to serve the user request. The extent of availability varies from system to system. So suppose you are designing a social media application, then high availability is not much of a need. A delay of a few seconds can be tolerated. Getting to a view the post of favorite celebrity on Instagram with a delay of 5 to 10 seconds will not be much of an issue. But if you are designing a system for hospital, data centers, bank, then you should ensure that your system is high available, because a delay in the system can lead to a huge loss. So there's a key difference of two different systems that has different requirements about the availability. And scalability in system design refers to the ability of the system to cope with the increasing load. While in design the system, you should keep in mind the load experienced by it. It's said that if you have to design a system for load X, they should plan to design it 10 times and test it 100 times. So there can be a situation where your system can experience an increasing load. So suppose you are designing an e-commerce application, then you can expect a spike in the load during a flash sale. So when a new product is launched for sales, these are very common in Black Friday. So your e-commerce has to be prepared to spike during the Black Friday. This is a good example of scalability in your system. In that case, your system should be smart enough to handle the increased load efficiently. It makes it scalable. In order to ensure scalability, you should be able to compute the load that your system will experience. So yeah, we have here some important points to consider when designing a software system.
Gabriel,
It, mm-hmm.
may I have a question?
All right.
Uh, what the difference about the scalability and besides
Elastic.
elastic?
Um, Let me see. Scalability, I guess in some contexts they are similar because you can uh enhance, improve your system scalability, use elastic service for example. Like we are talking about cloud service, you can use some elastic service. There is which is service that can be um, used across cloud service and can be get anytime you want. So um, is a great point to scalability. But yeah, I guess in this scenario is they are animals,
I,
but
I
mhm,
think that is I don't know, elasticity, it's a ability that the services or infrastructure can be increase and decrease faster.
yeah,
Uh, like you said on Black Friday scenarios, maybe if you put a commercial in a TV show, you go from 100 transactions per second to 1 million transactions per second.
mm-hmm,
You don't have a time to understand the new metric is based on CPU memory to add new servers, add new CPUs, add new uh, yeah. If the service is elasticity, you can it can grow faster uh, and reduce faster too, to save costs. I believe
yeah,
that
for sure,
the difference.
yeah, and yeah, scalability is more related uh to the whole system process, and Elastic, like you said, is more related to the service. So is one of the point of scalability.
Gabriel,
Uh,
may I question?
yeah.
Um, can you give me example? How can I improve my scalability in application? And we can uh, care about it only when I configuring my server in the example service from AWS, or I can apply some patterns in my project to prevent problems about scalability.
Do you want an example? How can I scale your system? Like
Yeah, how can
applying.
I use a pattern or architecture in my application to care about my scalability?
Okay, okay. Yeah, in general, the first approach that came in my mind is microservice. So you have to evaluate if your system can be split up in microservice, and then kids led to scalability. So you split your service in microservice and module that can run independently, and then can
Mhm.
easily led to scalability, increase your performance and reliability, for example. But like we said in past meetings, this can lead some bottlenecks or drawbacks, and then you have to evaluate if it makes sense to your scenario. But
Okay.
yeah, split it into microservices a good approach. Um, and yeah, about stacks, you can use, for example, Kubernetes to uh, to deploy these services in containers and scale these containers
Mhm.
while you're receiving requests is using uh, uh, horizontal scalability, so you increase the numbers of nodes in your Kubernetes. And yeah, but we have to see the scenario if it makes sense, because if you have, for example, a bottleneck in your system like the database. So for example, if you are using a Postgre relational database, it doesn't make sense using a microservice, because you're gonna increase the requests in your database, and then your system will go down in some moment.
So we
So
have this limitation. The communication with database represents a funil. Do you know, guys, funil in English?
it's bottleneck.
Bottleneck.
Right,
It's
Perfect.
so the database represents a bottleneck in our flow.
yeah, most of the cases is the main bottleneck. So yeah, you have to change it to another technology, another kind of database.
Do you have some
Um,
recommendation?
we have to evaluate the scenario, because you have different database to different user cases.
I got it.
But I can tell to you guys that my last job in iFood at iFood, we changed the Postgre to Elasticsearch. It was, and then we decreased the time of insert operation in 2 times. So it was a good choice. Um, And yes, you have to evaluate a scenario to choose the best approach.
Nice.
I can
And
think
then
of
you,
some approaches that may help on this matter. Maybe if you could use a proxy to handle a pool of connections. One of the greatest difficulties in databases are connections. If you have too
Mhm.
many
mhm,
open connections, it cripples the database. So you may use some approaches that involve some proxy, where you can handle a connection pool and serves that connection to the application. That's one approach. Another approach is a vertical scaling. That's why Elastic may be of service, because you can easily handle the increase of requests, increasing the memory, the storage, and so on and so forth. That's another approach that may be combined. You may use a third approach where you can even use a NoSQL database. Maybe if your operations of writing and recovering the data may be well served by a key value database or a document database, some of those NoSQL database, or even a graph database. I don't know. It depends, like Gabriel said, it depends, it's highly dependent on the scenario. But those would be
yeah,
some approaches that you could use.
yeah. You can use a Redis for cache, for example,
Yeah,
and
yeah,
then
caching. That's another thing. Yeah.
yeah, then
May I have
mhm,
uh,
okay,
uh,
go.
in general is more easy to scale horizontally besides vertical, because in general to scale in vertical there are have a downtime, yeah, because you need to shut down the machine and then add some CPU or more memory.
Great points.
In general, uh, some services can do that, but in general, uh, it's more easy, like I said, because the elasticity, because you can, when you use it horizontally, you can put another servers to attend the more requests from your API. And if you use some database that have a shard like MongoDB or Elasticsearch, you can put more machines in
Nodes.
shard,
Yeah.
more nodes in shard. When you use Kubernetes, you can put more nodes in your cluster. Uh, uh, there are depends of the situation to choose that. But some choices that you made in your software could impact the way to scale. Like if your API are how can I say, is not restful. If you armazen some sessions in your memory of your application, it maybe is more harder to scale in horizontally. You need to scale vertically. Because of that, the best approach is using RESTful to prevent this type of situation. But depends of the scenario. Yeah, if you use some web pages, you can use the content delivery network. There are many types of ways to scale.
I
Yeah.
have a I have
Good point.
a question about the horizontally and vertically. What is the conception between them? How can I improve vertically, and how can I improve horizontally?
Vertical scalability is related to increase resource in the same machine, like
Yeah,
uh,
more memory
like
and
more
CPU.
memory, CPU, and so on. Horizontal
More
scalability
instance.
is exactly more
Okay,
nodes and is just supported by uh, distributed systems.
okay.
So yeah,
It's like
like
a instance more pods of my application, the horizontally.
yeah,
Yeah, okay, thank you.
In general, when you apply some load tests, you can measure that one 10 pods can process 1,000 transactions per second. Yeah, if you multiply then for 10 with
Mhm.
100 pods, maybe you 10,000
Yeah.
transactions. Yeah, it's not true if you multiply your multiply your
software.
memory or CPU. Is not true because you can some the network is the same. You can achieve the same numbers, maybe depends of the situation.
So the pods can share some resource,
No, the
no?
pods are independent. Yeah,
Independent.
yeah, but or vertical you can add more CPU, more memory,
Mhm.
but uh, if you increase 10 pods, uh, multiply for 10, 100
Mhm.
pods, you can increase your capacity 10 times,
Mhm. I got it.
probably. Yeah.
Mhm.
But if you increase your vertical 10 CPU, 10 memory, maybe you to not achieve the same number, maybe
Okay.
8 times, 7 times, and much more expensive
Yeah,
cost.
and about the CPU, in the context of node example, we have one thread processing. It's a fact when my server is running in node.
No, your pod allocated a piece of CPU to process. Independently, one pod, two pod, one thread, two thread, you allocated a piece of CPU.
Mm-hmm.
Yeah. Uh, uh, 500 millicore, one core, two cores, 5 cores, 10 cores. Yeah.
Mm-hmm.
And Node will uh, maybe sometimes you know if you use it Node.js, uh, uh, sometimes uh, you don't, how can I say, you don't have effect to put more cores because Node.js
Mm-hmm.
has a single thread, but
Yeah.
depends of the situation. For Java, for .NET Core, you can prove that. But Node.js, the last version, can use some threads or instance multiple instance of your applications in different threads in the
Ah,
same
got it.
pod. Yeah.
So everyone, do not want to interrupt, but we only have 5 minutes left. If you guys would like to keep on going with the discussion, you can always message each other on Discord, or you can reach out directly to Gabriel. But Gabriel, very insightful presentation of yours. Thank you for bringing that onto us. And soon enough, we'll be doing system designs interviews here.
Yeah.
Cool, thank you. Igor, you may take it away.
Awesome, guys. Really great, really productive conversation, discussion today. Have just some notes on grammar, vocabulary, and a little bit of pronunciation. First things first, on grammar, justify each choose that you make. So choose is the verb to choose. When you have when you choose a thing, you've made a choice. So choice is the noun, is the thing that you make. So you justify each choice that you make. If you can understand more clear the problem, let's try to rephrase this and say in a better way. If you can understand the problem
Clear.
more clearly, okay? So if you can understand the problem more clearly, sounds better. It's a more fluent way to say this. What is the problem with this phrase, guys? The third one. Somebody tell me. This is something that I always say to you every class. In general, it's more easy to scale vertically than horizontally. What is the mistake here?
More easy.
Is easier.
Perfect. Not more easy, it's easier. I say this to you guys every day. Easier to scale vertically than horizontally. And another thing, I think this was you, Marcel. You were saying, "Oh, how do I do this? How do I do this to care about my scalability?" So you're saying in the sense of like to maintain my scalability, to deal with my scalability. To care here would be like you were saying, me preocupar in Portuguese, which makes sense, but not a lot of sense. You want to say that you want to deal with that, you want to solve that. So how to deal with my scalability, okay? To deal with something you are working with that, you're trying to solve that. Another thing, the word fundaments does not exist in English. You can say principles, which I think sounds the same thing, like the fundamental truth or belief that guides action and decisions. So you can say those are the principles of system design interviews. The word fundament does not exist. Elastic, the ability to quickly expand or decrease computer processing, memory, storage resources to meet changing demands without worrying about capacity. So elastic. And bottleneck, a point where everything starts straining out and it forms a point of congestion or blockage. So databases are usually one of the bottleneck on a system or something like that. Now for pronunciation, I ask you guys to repeat after me. it's oh sorry, it's not it's not compo wait, how do I say? It's not
Components.
yes, it's not no, I guess you said it right.
Component.
Component. It's because your guys were saying it another way, but I can't even remember. But it's component.
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 Components.
Component.
Yes. I think you guys were saying components,
It's
something
not
like that.
Yeah.
The stress syllable is in the component.
component. Components.
Perfect. Scalability,
The scalability.
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 authentic, wait, is authentication?
Authentication.
I always thought it was authentication.
No, it's
Authentication.
Yes, authentication.
Authentication.
No, there's no F. There's no F.
It's
There's no F.
Yeah,
It's
authentication.
Authentication.
yeah,
Authentication.
Authentication.
Living and learning.
We said authentication 20 times.
Everyone was like parrots repeating the same
Authentication
message.
and authorization.
Reliable.
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 Oh my God.
There's a lot of people today. Elasticity
Elasticity.
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 and independent.
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 Perfect. So I'd like to see a full class today.
Yeah,
Does
our
anybody have?
family are growing.
Yes, our family is growing. Does anybody have questions, doubts, tips, jokes?
I just want to
Disbeliefs.
say thank you for sharing this rich knowledge. It was
Yes.
very, very, very interesting.
Thank you, Dan. Thank you,
Yeah.
Gabriel. Let's give
Nice.
Gabriel.
And Carlos, Gabriel and Carlos with the
Carlos,
connection.
yeah. Carlos.
Yeah, it's nice to
Thanks
have
so
you
much,
back,
guys.
Carlos.
Yeah, our architect.
I
Please
talk
don't
too much.
Yeah, don't forgive us.
What do you think, you guys? We keep talking about system design every week. Like we can jump to the next article about it.
Perfect. That
That's
I
sounds
good.
good.
appreciate it.
Yeah, let's do that. All right, let's wrap up with the picture now. Have to jump up to another meeting. Count of 3. 1, 2. All right,
Nice.
I think this is working. I'm getting used to Windows now.
Windows is great,
Ah,
Ansel.
you're a PC gamer.
PC
Yeah,
game.
my Windows is up and running. Marcel, we're gonna play 7 Days to Die this weekend.
Yeah.
Oh yeah, I'll play with you
This-
guys as well.
Yeah.
All
But
right,
Ansel's
everyone.
really happy that he can take screenshots right now. He can
Yeah,
share his
that's-
screen, no problem.
That's my biggest achievement. And I can download everything now. All right, everyone. Thank you so much for today. We'll be seeing each other tomorrow for mock interview days. So get
You
ready.
guys.